Hey everyone, in today's video, we're going to see about LoRa, low rank adaptation. Have you ever thought of fine tuning LLM? LLM, we know, right? It is a large language model. It will be used for summarizing, classification, and other text based applications or use cases. It is a like large NLP cloud kind of, I mean, the brain. And we just use these things for multiple uses. Since it's like generic and it is trained with, huge text vocabularies, it understands those things. But have you considered using it in, in a simple way? I mean, in a small size, like transferring into your simple GPU, running your model in your local, and performing tasks for your specific use cases. Have you ever thought of it? So it is easy, it is simple because we have LoRa to do that. Because if we are like having this large language model, we can just actually fine tune it to have it for a specific task. Like I wanted to summarize my own text. For example, I follow certain things like I'm a chef, okay? Just imagine I'm a chef. And I wanted to write recipes based on the ingredients that I give, and it should understand my language of cooking. So I follow certain way of cooking. So I just going to teach the model my style to it. Can I have that? But I can't just have that in large language model because it is too generic to have one, but it understands some of the recipes, ingredients, style, everything. But can I fine tune it? If I go with large language model, just imagine like I have this LLM which is fixed, and if I fine tune with my set of data, it enlarges. So we have this form of more data to it, and it is very expensive. So I am going to fine tune it, which in the form of compression. This is like another way, and is going to use the base model of it and going to add some of the weights on my own, the parameters we say on my own. If I do this, I'll have the base model as it is without changing it, but it will behave for my new data. Let me just give you like on a simple way, like how LoRa, I mean, what is fine tuning is. You have like large book. Okay, let's say like you have a book. Okay, everything is box here because I don't know. I don't want to spend much time in drawing and all. Just bear with me. So we have like it's a book. Just imagine it's a book, and it is like around of 20K pages. Large language model is like something huge, I know, but let's have like 20 pages in this book. So I just wanted to teach someone, but I'm completely new to this field and for this book. So what I do is I just add a sticky note to it. I just give this book to a person who actually know about it, and they just add sticky notes to it. Sticky note here and there, every pages like small notes about each topic, and it is like form of summary to it. So if I do this, I'll have like around 20 pages. I can have like 20 sticky notes. Just imagine like I have only 20 sticky notes. So which is easy. This is expensive and I cannot store anyway. I cannot save and work or perform tasks and locally. But here I can do anything with this. I can save locally. It is cheap. Local, I mean, the memory is, oh, sorry, memory. Everything is like very feasible and it is achievable also. This compression is achievable. Now we'll see like how to do this. A simple mathematical equation that I'm going to teach, which will be helpful for you guys to understand what actually this LoRa does. Okay, let me erase this. Okay, and just change the color. What color? Orange. Let's take orange. And here, let's take sky blue. Okay, it looks good. Fine. Now we have a matrix, which is our base. A frozen, we can say, like frozen. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have this matrix, which let's say like it's our LLM. And we can just change any of these. And it's constant. We're not going to change any of that because we are going to add our own parameters. Let's say A of height with a rank R and B of width, weight of rank R. So we're just going to assign weights. These are weights, I know. These are like fixed weights, which is trained, I mean pre-trained. It's in generic format, and we can just go to use all of those things like a regular one, like generic format. But we are like going to fine tune it, right? So for that, we are adding weights to it. Let's say, okay, another color. A is on height 0.1, 0.2, 0.3. On the P and the side with width 1, 0, -1. Okay. Now we're just going to do this ranking, I mean low ranking to the fixed weight. In the sense, we're just going to do here, it is like compressing in the format of dimensionality reduction. You guys know, right? Like the PC stuff, like reducing the dimensionality reduction, like reducing the features, size of it, so that we won't have this overfitting and have the model which will predict accurately. The feature engineering stuff, it is similar to that, not same, but similar kind of, which is going to do that. The multiplications, yeah. So it just is. So yeah, we can have the output as 0.10 minus 0.1, 0.20, 0.2, 0.30 minus 0.3. Beautiful. We just have these multiplied with this one. What do we have now? We have weight, which is fixed, and we have multiplication of the new values, which is used for fine-tuning the model. And okay, so we need to do these two calculation. Weights we know, that is like the fixed one, and fixed in this case the frozen one, which is your pre-trained weight, and which is going to add the multiplied weights that we have, something like parameters, we can name it parameters. And finally you will have your tuned weights. You can fast forward this if you want. Okay. So that's it. And finally, we are having this fine tuned weights. It is less compared to the previous case, and it had it more feature to it, which will be performing for our own task. How I said like fine tuning in the sense like you can see the weights, right? The size of it. Here it is 6, and here it is like 5.8. Here it is 3, and we have like 2.9. And here it is 9, and we have 8.7. You can see like, oh, point 0.3 is different, point 0.1 is different, but it does a huge impact in your large language model. And that is how this entire training, I mean, the fine tuning works. And this is what LoRa does. So next time when you are going to reduce or compress the size of LLM for your own set of tasks, you can just play with it. You don't have to technically go with the actual model. We can go with something like fun or open source. You can try with open source data. So that is how it works. And it is a good practice in current days. And just understand what it is. You can rewatch this video again and again a number of times. If you didn't understand any of these things, just comment below. I can help you with. Thanks, guys. Bye. Bye bye.